You're good.
Yo, what's up, everybody? This is Evan here from ES Van Ness Mechanical Plumbing and Heating. Just coming to you guys today about some information about high efficiency boilers. Just wanted to let you guys know about some of the incentives that are out there from the city, especially if you're dealing with PGW or you talk to your local energy provider about the rebate and stuff they have out there. For a high efficiency boiler, it's got to be 95% efficiency or higher, if I'm not mistaken. But if you're thinking about replacing a boiler or going new, PGW has a $1,500 rebate you can get when you convert from an older style cast iron boiler, on the floor, the cast iron, big cast iron heat exchanger, your typical normal boiler you see. If you go high efficiency, they're offering $1,500 rebates. And if you have an oil tank in your house and the gas line, if you had like gas run but your old system was run off oil and you just never changed it, if you convert from oil to gas, they have another $500 rebate you can get on top of that. So if you were to use those two rebates combined on a new unit, that's $2,000 you get back from PGW. That right there in itself could pretty much pay for the unit for most size houses out there. Sounds like a pretty good deal. So that's just some useful information I like to put out there for the homeowners. But like you can see, we took out an old boiler here that was from like the early 1900s, 1920s. Early old boiler. They converted it to oil. We got rid of that. Took them from the Stone Age to the 21st century. We also installed Bradford and White tankless hot water heater. Infinity series, 199,000 BTU. As you can see, compact, close to the wall, mounts on the wall. Hot water instantly. Just another thing I want to say too, as far as tankless hot water heaters, okay? Tankless hot water heaters, if you have a big family, wife, kids and all that, you might want to think before you get a tankless hot water heater if you've been thinking about getting one. Especially, main reason due to being in the wintertime, okay? People think, oh yeah, tankless hot water heater, I get hot water out, endless for hours. Yes, but it all has to do with the temperature. Okay, in the summertime, when it's warm outside, that means the water out in the street's a lot warmer due to the temperature. So this can run all day, 6 fixtures, keep going, you'll have hot water. But what a lot of people don't take into mind or keep in mind is when it gets cold out and that water out in the street is 40 degrees, okay, the recovery on these is nowhere near what it is in the summertime. Okay, so you being able to run six fixtures at one time, which I know a lot of people don't. I'm just saying if you have a big family and stuff like that, you want to think about before you get a tankless hot water heater. If you have a lot of people living in your house, because that fixture rate goes from being able to run 6-7 fixtures at one time down to 2.5, because this thing has to work hard to cook that water from 40 degrees up to 110 or 120. The recovery isn't going to be fast enough to give you the supply you want, so you're not going to have enough hot water that you need. In the summertime, when the water is 70 degrees out in the street, that's less work that the tankless hot water heater has to do to get. So think about it, 70 to 120, less work. 40 to 120, it's a lot more recovery, it's a lot more work, it can't keep up. But if you're a smaller family or it's just 1 or 2 people living there, this should be plenty. What I would recommend is just go with the traditional hot water heater for volume, for larger families. You could get one that runs off your boiler, a hot water storage tank. You could get your standard one that sits alone by itself. But as you can see here, we got everything piped up, nice, brand new. It looks like a lot, but it's really not. It's a simple concept. All this is water going around in a circle. You got to understand what things are that are in place. It's just for safety and to keep everything running right. So I'll give you a brief lowdown on how this is all working. All right. So if you take a look here, we got our water coming in off the street. Okay, 3/4 line coming in off your meter. All right, comes in, comes over. All right, we got a T up here. You can't really see it, but it tees up and over. Okay. Off the bottom of the T in the run, it keeps coming over. Okay, we come over. This feeds our tankless hot water heater. All right, so what we have in place, got a shut-off valve to shut it down, isolate it, okay, in case we got to work on it or whatever the day may come when they want to replace it. Shut-off valve, okay, check valve, and then we have a T come down to a 1/2-inch line that comes over to an expansion tank. Okay, since we got a check valve in here, we got to have the expansion tank. Okay, if water's not running through there, it's technically partially like a closed system. Okay, that check valve closes. Now what happens when water heats up? It expands. It's got to have somewhere to go. Okay, so we put the expansion tank in here. In the expansion tank, there's a bladder that sits right here with air on. It's charged to a certain pressure. There's air underneath. Water sits on top. And as the water heats up and expands, the bladder is able to compensate. Okay, if this was broken or if this filled up with water, if it went bad, you have the tendency your pressure relief valve could blow off. Okay, so with that being said, cold water comes in. Okay, behind, got a union, cold water in, does its thing, hot water out. Okay, another union to be able to take the unit off the wall if something ever needs to be done to it. Okay, off the top, 90, come over, another shut-off valve for the hot water, and boom, hot water goes and feeds the rest of the house. Okay, it shuts the hot water down to the house. All right, now we'll come back over to what goes on with the boiler. All right, here's our cold water line again, tees up, comes over up top. See it up here, 3/4 line comes up off the top. Right, comes over. Got a 3/4 by 1/2 T to come down and feed the boiler. Off of that, cold water to feed the rest of the house. All right, so we got our hot and our cold for when they're ready in this house. You know, they can convert the packs or whatever they want to do, and they can go out and that'll feed the rest of the house. Back to the boiler, 3/4 by 1/2 T. All right, so here we go. We're coming down. Boom. All right, this is essential. I always preach this. Okay, you want to have this on your feed system going into a boiler. This is very important. All right, one for safety and two to keep the boiler running properly. All right, got a shut-off valve to shut everything down to stop water to get into the system. Okay, then we have here what's called a backflow preventer. This is what keeps this hot water in the heating system, okay, from getting back into your drinking water. All right, a lot of places just have I see it in a lot of houses, and I've said this many times before. You just have a shut-off valve here and nothing else going to whoever piped up. Okay, if somebody was ever bump this or open this or something like that, now you got cross-contamination. Okay, this water can make its way back into your drinking water. You don't want to be drinking that water inside your heating lines. As you can see, these old pipes that have been around here for a long time. You don't want to be drinking what's in that water. So what this device does, it separates it and keeps you safe. It keeps that water from being able to come back. It's another check valve, spring-loaded, okay, that stays shut. But water's allowed to get in when the boiler needs water, okay? Pressure reducing valve, okay? This takes you down from street pressure to working pressure for a heating system, a hot water heating system, between 12 and 15 pounds. Okay, out here in the street, you could have anywhere between 50 and 100. Okay, you can't have that pressure coming into your boiler because your relief valve, your pressure relief valve on your boiler is going to blow off because that's set at probably around like 35 pounds. Okay, so pressure reducing valve. So we got 50 pounds of, between 50 and 100 pounds of pressure on this side, 12 and 15 now. All right, come in, boom. Another expansion tank, because now this is a closed system. We got the check valve in here, right? Backflow preventer, form of a check valve. So now the water's got nowhere to go when it heats up and expands. So this has a bladder and the top half's filled with water, bottom half's got air in it, right? You can hear it pinging. Hear the difference? I don't know if you can hear it. I can hear it. All right,
yeah,
so it goes up. And then we got our air scoop. This separates the air, helps get air out of the system as it gets introduced in the system, and also as it gets pushed through with the circulators, with your high vent on top. Okay? This is to fill the system up and give the boiler water when it needs it. All right? Now we'll get back to this stuff in a second. We'll come over here to the boiler. All right? This is a Crown Velocity Series Shadow boiler. High efficiency, like 95% efficiency rating. Got the digital readout for your controls. Okay? So on here on this boiler, right? These two lines coming out of the bottom are your supply in the front and your return in the back. All right, got a pressure temperature gauge in the front so you can see what the temperature is leaving the boiler. You can also see the temperature on your digital readout. Okay, so what we got? Supply comes down. We roll back to the wall, keep everything uniform. We got a union. We got a union here to, if we ever got to break, we break that loose to get to the boiler. If we ever got to take it apart or take it off the wall. Okay, so that's to help break everything loose. Shut off valve. Okay, we shut the water off, so when if we ever had to break that loose, we won't get water flying back to us. All right, shut off valve. Now we come off, right? Boom, feeding the system. Right? Comes across, boom, comes up. Now we got a T here. All right, I'll explain what that is in a second. But water, we're gonna go off to the left, right? Water goes off to the left and goes up in supply. All right, supply comes up. Boom, through the air scoop, high vent, system circulator, okay? Back down, up, shut off valve to isolate the system. If we ever had to work on any of this stuff, we would shut this valve off so we don't get water from the whole rest of the house coming back down and flooding everything up, all right? And it's less water we gotta drain out, so we would shut that off, all right? Supply comes up, boom, comes out. Ties into our two existing supply lines that were already here in the house from the old boiler. Goes out, supplies heat, okay? These two lines back here are our return lines, okay? Hot water goes back, hot water goes out to the baseboards, convectors, radiators, whatever you got. All right, disperses its heat. Cooler water comes back, right? These two lines. We got them coming back. Boom, here we go. T, right? Return line comes back down, snakes its way through. Okay. Behind here, behind the T for the gas, we got another shut-off valve to isolate it, shut it down in case we had to work on anything and keep all the water from coming back down on us. All right, shut-off valve. Boom. And we got a strainer. And we got a check valve. Okay, another check valve. What that does is it keeps the water going in the right direction. It doesn't allow it to go back in the wrong direction. All right? Now back to this T that I was talking about before, right? Supply going out, return coming back. What this T is, these two T's are makes your what's called a boiler loop. Okay, for these high efficiency boilers, you gotta have a boiler loop. All right? So what that means is, all right, return comes back, goes in, shut off valve, circulator, okay? This circulator is pulling water back to the boiler. It's pulling, it's going in that direction. All right, this is your boiler circulator, okay? The boiler circulator, that's your system circulator, all right? What this does is it moves the water around in what's called the boiler loop. Okay, so that's what these T's are for. Your supply comes down off the front, comes down underneath, comes through, and it does a small loop process, all right? This water is constantly being looped together. What that does is it mixes it pulls some of this warm water from the supply back in with the return to mix it, to make the water warm, a little bit warmer than what it is coming back, because that water's a few degrees cooler when it comes back from dispersing all this heat out the baseboards, radiators, convectors, whatever you got. So if you understand what I'm saying, everything, warm water and cooler water, they mix here. All right, well, I should say hot water and cooler water mix here to make warm water, and that goes back into the boiler. Reason for that, boiler doesn't have to work that hard to recook the water, and plus you won't shock it. All right. And last but not least, the pressure temperature gauge to see what we are coming back to the boiler to make sure the temperature's all right. I like to always put those in there so you can see what's going on. Your supply and your return. Okay, this way you can make sure there's not a big pressure or a temperature difference going on in there. But as of that right there, that pretty much sums it up on how these boilers work. Same thing, same concept with the larger boilers, but for these high efficiency ones, they're a little tricky too. You got to be careful. These circulators that you use on the high efficiency boilers, okay, these aren't your Takeo 007s, your normal standard those circulators. These ones are a little bit more beefed up because you got flow sensors in there, and you got to have a certain flow going through. And if the sensor doesn't see that it's getting enough water fast enough, this thing won't even start. So you got to pay attention to that when you're putting these high efficiency boilers in. But that's just a couple little, tips and some information for you guys out there, some other plumbers out there getting it. Yeah, that's it. Pretty self-explanatory. You got your exhaust and your fresh air intakes on both units. All right, going outside. I use concentric vents so they tie together, but the two gases are separated inside where it goes through the wall. That alleviates having to make 4 holes through the wall if you have to. I mean, with this house, it was an old stone house, so I just wound up being one big hole. They passed it up with concrete, but the reason for concentric vents is to eliminate penetrations going through the wall. But other than that, yeah, that's it. I hope you was able to get some information. ES Van Ness Mechanical Plumbing and Heating. You can reach out to me via social media, telephone, whatever, email. You can go on my page and get all that information, all right?